Hello students and good morning. So now I'm doing class for class 12 science. The topic is integration by parts. And in the last online class also we were doing the same topic, that is integration by parts. So today is the continuation class of this chapter. So we will do the same exercise, that is exercise 7, 4-mark section, page number 380 from the book Higher Mathematics for class 12 by Sailendra. So let's do this question number 28. So let us evaluate this integration, that is integration of cos inverse x divided by x cube dx. So in this case also this is integration of the product of two different functions. So you have to use integration by parts. So first of all let us write I is equal to integration of x cube is taken to the numerator, so it becomes x to the power minus 3, and this is cos inverse x dx. Is that clear? So now what will you do in the next step? So this is the integration of the product of two different functions, so you have to use integration by parts. So x to the power minus 3, which function is this one? This is an algebraic function, that is a, and cos inverse x is inverse circular function, that is I. So there are two letters here, a and I. So in the word let or ilet, which letter comes first, a or I? So I letter comes first in the word let or ilet. So inverse circular function is the first function, that is cos inverse x is the first function and x to the power minus 3 is the second function. So let us use integration by parts here. So which is first function is taken outside, that is cos inverse x integration of x to the power minus 3 dx. Then you should write minus integration of second bracket dy dx of this is your cos inverse x integration of x to the power minus 3 dx, second bracket closed, it is dx. Is that clear? So this is your integration by parts. Okay. Now let us first integrate. So I is equal to, what is integration of x to the power minus 3? It is x to the power n plus 1 divided by n plus 1. So if you use the formula, you will get x to the power minus 2 divided by minus 2, and this is cos inverse x minus integration of. Now what is dy dx of cos inverse x? You can use the formula. What is the differentiation of cos inverse x with respect to x? It is minus 1 upon root over 1 minus x square into, what is integration of x to the power minus 3? It is x to the power n plus 1 divided by n plus 1. That means you will get x to the power minus 2 divided by minus 2. That is x to the power minus 3 plus 1 divided by minus 3 plus 1. That is x to the power minus 2 divided by minus 2. Then what do we write here? Dx. Okay. So or I is, let us simplify it. This minus sign is taken outside. 1 upon, this is taken to the denominator. So it is 2x squared. It is cos inverse x. Right. So minus into minus plus, plus into minus is minus. This is half. Integration of minus into minus plus, plus into minus is minus. 1 upon 2 is there. Integration of this is 1 upon, it is taken to the denominator, make it x squared. This is x squared, then within its square root, it is 1 minus x squared. Then what do we write? Dx. So I think you have understood it. Again, you have to integrate this function. Let us write it as I1. Or I is equal to minus 1 upon 2x square. This is your cos inverse x minus this is I1. Okay. So let I1 is equal to, so let I1 is equal to, what is it? It is half integration of, it is half integration of dx divided by x square root over 1 minus x square, this is root over 1 minus x square, right? So I1 is equal to half integration of 1 into dx is dx divided by x square root over 1 minus x square. So now how can you evaluate this integration? Now what is the method? So you have to consider the expression under square root. So within square root there is 1 minus x square. So in this case you can do the trigonometric substitution. So I already told you that whenever there is 1 minus x square within square root, you always put x is equal to sine theta. You know that, isn't it? So let x is equal to what? It is sine theta. So differentiating both the sides with respect to theta. Okay, so therefore this is dx by d theta is equal to, this is your cos theta. So dx by d theta is equal to cos theta. So let us do cross multiplication here. So dx is equal to, this is your cos theta d theta. So now what does I1 become? Let us put it in I1. I1 is equal to half integration of what is dx? It is cos theta d theta divided by what is x square? Here x square is sine square theta, and within square root we have 1 minus sine square theta. So I think you have understood it. Okay, so let's simplify it. Or I1 is equal to half integration of, this is your cos theta d theta divided by, this is your sine square theta into, what is square root of 1 minus sine square theta? This is your cos theta. So here cos theta will be cancelled. Or I1 is equal to, this is your half integration of, now let us simplify it. So what is 1 upon sine square theta? It is cosec square theta. So this is your cosec square theta d theta. Now you can easily integrate this integration of cosec square theta d theta. So what is the integration of cosec square theta? It is minus cot theta. You know that, isn't it? So or I1 is equal to, this will be minus half. Integration of cosec square theta is minus cot theta, right? So it is minus half cot theta plus c. Minus half cot theta plus c. Is that clear? But you should write down the value for I1 in terms of x. We know that sine theta is equal to x. So cot theta can be written in terms of sine theta, isn't it? So or this is I1 is equal to minus half, what is cot theta? It is cos theta divided by sine theta plus c. Or this is I1 is equal to minus half into, let us convert this cos theta in terms of sine theta. So root over this is 1 minus sine square theta divided by sine theta plus c. Or now this is I1 is equal to minus root over 1 minus, let us put the value for sine theta. Here sine theta is equal to x, so this is your x square. Whole divided by 2 into x, this is 2x. Then what do you write? Plus c. But this is the value for only I1. But you have to get the value for I, isn't it? So let us put this value for I1 in I. So this I becomes now. So therefore I is equal to, what is the first term here? Minus 1 upon 2x square, minus 1 upon 2x square, then this is cos inverse x, right? So there is minus I1. Because of this minus, sign will be changed. So minus into this minus will be plus. So root over 1 minus x square upon 2x. Okay? So minus into plus is, that is your minus c, but since c is a constant here, you can write down it as plus c. We can write minus c or plus c. So this is only the constant of integration. Either you can write plus c or minus c. So this is only constant. Okay. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 29. You have to evaluate this integration. That is integral of tan inverse within its square root. There is a fraction 1 minus x upon 1 plus x dx. So how can you evaluate this integration? So let us first write I is equal to integration of, this is tan inverse root over 1 minus x upon 1 plus x then dx. So in this case you have to do the trigonometric substitution for x. So what should you put for x so that you can use the formula both in the numerator and in the denominator? So in the numerator we have 1 minus x and in the denominator we have 1 plus x. So what should you put for x so that we can use the formula both in the numerator as well as in the denominator? So you should put here x is equal to cos theta, because if you put x is equal to cos theta, you know the formula of 1 minus cos theta as well as 1 plus cos theta from trigonometry, that is from submultiple angle. So let us put, let x is equal to what? It is cos theta. So let us differentiate it, differentiating both the sides with respect to theta. Therefore dx by d theta is equal to, what is the differentiation of cos theta? It is minus sin theta, right? Now let us do cross multiplication. So dx is equal to, this is minus sin theta d theta. So let us put these values in I is equal to integration of, this is your tan inverse within square root. What do we write? 1 minus cos theta. This is 1 minus cos theta divided by 1 plus cos theta into, and what's about dx? What is dx? It is minus sin theta d theta. It is minus sin theta d theta. Is that clear? So now let us simplify it. This minus sign you can take it outside integration. So therefore I is equal to minus integration of, right? Then you should write tan inverse. Tan inverse, now within square root, what do we write here now? What is 1 minus cos theta? It is 2 sin square theta by 2. It is 2 sin square theta by 2 divided by, what is 1 plus cos theta? It is 2 cos square theta by 2. It is 2 cos square theta by 2, okay, into sin theta d theta. Into, you should write here sin theta d theta, minus sign is already taken outside, okay. So here 2 gets cancels, or I is equal to minus integration of tan inverse. So within square root there is sin square theta by 2 divided by cos square theta by 2. That is your root over tan square theta by 2. What is square root of tan square theta by 2? That is your tan theta by 2. So it is tan theta by 2 into sin theta d theta, right? So or I is equal to minus integration of, what is tan inverse tan theta by 2? This is your theta by 2 into, we have here sin theta d theta. Now again which constant is taken outside? Minus half integration of theta. This is sin theta d theta, okay. So now theta sin theta is there. So this is also the integration of the product of two different functions. So here also you have to use integration by parts. So here you know that theta is an algebraic function, that is a, and sin theta is trigonometric function, that is t. So in the word letter I let a letter comes first, then t, okay. So theta is the first function and sin theta is the second function. So or I is equal to, this is your minus half within third bracket. Let us use integration by parts. So theta is taken outside, integral sin theta d theta minus integration of second bracket dy d theta of theta, integration of, this is sine theta d theta, second bracket closed d theta, then third bracket is also closed. Okay, next, or I is equal to minus half within third bracket theta into, what is integration of sine theta d theta? This is your minus cos theta, right? Minus integration of dy d theta of theta is always 1. You don't have to write it. What is integration of sine theta? That is minus cos theta. Then you should write d theta. Third bracket is closed. Is that clear? So now multiply by minus half here. So I is equal to this minus into minus plus half theta cos theta, right? Minus into minus plus, plus into minus is minus. Then you should write half. So this is half integration of, this is your cos theta d theta. So I think you have understood it. So now in the next step, let us simplify it. Or I is equal to, what do we write? Half theta cos theta, that is the first term, half theta cos theta, minus half into, what is integration of cos theta? Minus half into, what is integration of cos theta? That is your sine theta. That is your sine theta. Then what should we write? Plus c. So I think you have understood it, but this is not the answer. But this is I in terms of theta, but you should get the answer in terms of x. So from here, what is x is equal to cos theta? So now what is theta is equal to? This is your cos inverse x. Is that clear? So let us put the value for theta here. Or I is equal to half, what is theta? What is theta here? This is cos inverse x into what is cos theta? That is your x. Cos theta is x minus half. Now let us write down sine theta in terms of cos theta, so that we can put the value of cos theta which is equal to x. So half root over, this is 1 minus cos square theta plus c. So or I is equal to, this is your half, then write down x, then this is cos inverse x, then minus half root over 1 minus, what is cos square theta? Your cos theta is x, so it is x squared. Then what should you write? Plus c. So this is the final answer. So this question is very, very important. So you can mark it. Okay. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 30. So you have to evaluate this integration, right? That is integral of sine inverse x divided by, in the denominator within bracket there is 1 minus x square whole to the power 3 by 2, then dx. Okay. So let us first write down, therefore I is equal to integration of, this is sine inverse x divided by 1 minus x square whole to the power 3 by 2. Then you can write dx. Okay. So now in this case you have to do the method of substitution. And you know that the differentiation of sine inverse x is 1 upon root over 1 minus x square. So that means you have to simplify 1 minus x square whole to the power 3 by 2. So how will you write 1 minus x square whole to the power 3 by 2? Now, so or I is equal to integration of, this is your sine inverse x divided by 1 minus x square whole to the power 1 plus half. Can you write it? This 3 by 2 can be written as 1 plus half. so that you can separate this term, that is dx, right? So now you should know how to separate this denominator, integral sine inverse x divided by, you should write it as 1 minus x square whole to the power 1 into 1 minus x square whole to the power, this is half, right? Then you can write dx. So now 1 minus x square whole to the power 1 plus half can be separated as 1 minus x square into 1 minus x square whole to the power half. And you know that whole to the power half means within a square root, isn't it? Or I is equal to integration of, this is your sine inverse x dx divided by 1 minus x square, then within a square root we have 1 minus x square. That means 1 minus x square whole to the power half means it is within a square root 1 minus x square. Is that clear? So now how can you evaluate this integration? And you know that differentiation of sine inverse x is 1 upon root over 1 minus x square. There is 1 upon root over 1 minus x square. So let us assume z is equal to sine inverse x. So let z is equal to what? It is sine inverse x. So now let us differentiate it. So differentiating both the sides. So differentiating both the sides with respect to x. So what do we get? That is dz by dx is equal to 1 upon root over, this is 1 minus x square, isn't it? So now you can get the value for dx divided by root over 1 minus x square. So let's cross multiply by dx out there, okay? So now we have here, or dz is equal to, now let us cross multiply by dx. So it is dx divided by root over 1 minus x square. That means we have got the value for dx divided by root over 1 minus x square, which is equal to dz. But since we have 1 minus x square here, you have to put the value for x in this case, 1 minus x square. In 1 minus x square you can put the value for x, which is, from here you can get the value for x. So here x is equal to, this is your sine z. Is it understood now? So let us put these values in I. So therefore I is equal to integration of, what is sine inverse x? It is z. Z into, what is dx upon root over 1 minus x square? It is dz. Right? That is dx upon root over 1 minus x square is dz. And what's about 1 minus x square? So it is 1 minus, what is x square here? X square is sine square z. Right? So, or this is I is equal to integration of z dz divided by, what is 1 minus sine square z? It is cos square z. Okay? So what is 1 by cos square z? It is sec square z. Or I is equal to integration of z into, this is your 1 by cos square z is sec square z dz. Now you can easily integrate it. This is integration of the product of two different functions. Here z is algebraic function and sec square z is the trigonometric function. And you know that algebraic function is the first function and trigonometric function is the second function. So you can use integration by parts in this case. Or I is equal to, now z is taken outside, z integration of, this is your sec square z dz minus integration of, second bracket is opened, dy dz of z integration of, this is sec square z dz, second bracket close dz. Is that clear? So now this is integration by parts. We have used formula for integration by parts. So let us simplify it again. Or I is equal to z into, what is the integration of sec square z? That is differentiation of which function is sec square z? That is your tan z. That is your tan z. Then minus sign is there. Now integration of, what is this? dy dz of z is 1 always, isn't it? Dy dz of z is always 1. So what is integration of sec square z? It is tan z, then again it is dz. Is that understood now? So let us simplify it further. Or I is equal to z tan z. Now what is integration of tan z? Either you can write integration of tan z dz as log within mod sec z, or you may write minus log within mod cos z. So let us write here minus log within mod cos z. So minus into minus plus log within mod cos z mod sign closed plus c. Is that clear? But you should write down the answer in terms of x. Or I is equal to, what is z here? Z is sine inverse x, into, what is tan z? It is sine z by cos z, right? Plus log within mod. How will you write down cos z? Cos z, you have to write it in terms of sine z. This cos z, you have to write it in terms of sine z. That is root over 1 minus sine square z. 1 minus sine square z mod sine closed plus c. Okay. So or I is equal to, this is your sine inverse x into, what is sine z? Sine z is x divided by root over, you should write it in terms of sine z. That is cos z in terms of sine z is root under 1 minus sine square z plus log within mod root over 1 minus, what is sine z? It is x. So it is 1 minus x square mod sine closed. Okay. Then here you can write base e, base e, base e. Okay. Or I is equal to, now in the numerator we have x sine inverse x divided by root over, this is your 1 minus, what is sine z again? It is x, 1 minus x square plus log base e within mod, we have 1 minus x square, this is whole to the power half mod sign closed plus c. Now since there is log here, this half becomes the coefficient. That is, you can write this half before log, right? So or I is equal to, this is x sine inverse x divided by root over 1 minus x square. Okay, plus, now half becomes the coefficient. This is half log within mod 1 minus x square mod sign closed, the base is e, then you should write plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 31. So you have to evaluate this integration. The question is integration of x dx divided by 1 plus sine x. So how can you evaluate this integration? So in this case, for 1 plus sine x, we cannot use submultiple angle form here. Okay, we cannot use the formula in this case. So let us multiply both the numerator and the denominator by 1 minus sine x. It is just like rationalizing the denominator. Actually, this is not the rationalization. Rationalizing means you have to remove square root. Rationalizing the denominator means you have to remove square root from the denominator. But here, there is no square root out here. It is just simplified. So if there is 1 plus sine x, you should multiply and divide it by 1 minus sine x. Okay. So let us do this one first. I is equal to integration of x into, this is your 1 minus sine x dx divided by, this is also 1 plus sine x is multiplied by 1 minus sine x. That is, we are simplifying it. so that it will be easier for you to integrate it. That means since there is 1 plus sin x is in the denominator, you should multiply both the numerator and the denominator by 1 minus sin x. That is opposite sign, 1 minus sin x. Okay. So or I is equal to, this is integral sin x. This is your 1 minus sin x dx. It is kept as it is, divided by what is a plus b into a minus b? A square minus b square. So it is 1 minus sin square x, right? So or I is equal to integration of x within bracket. This is your 1 minus sin x dx. And what's about 1 minus sin square x? It is cos square x. Okay. So now let us simplify this trigonometric function. So which is the trigonometric function here? 1 minus sin x upon cos square x. So let us simplify it further. I is equal to integration of x within bracket. You can separate it. 1 upon cos square x minus, this is your sin x upon cos square x, bracket closed. Then you can write dx. Is that clear? So let us simplify it. Or I is equal to integration of x within bracket. What is 1 by cos square x? It is sec square x minus, what is sin x by cos square x? How can you simplify it? Sin x by cos square x, how can you simplify it? It is sin x by cos x first. So it is tan x. It is tan x into, then what is 1 by cos x? It is sec x. It is sec x, bracket closed. Then you can write dx. Is that clear? Now you know that this is the integration of the product of two different functions. Okay, so you have to use integration by parts. Here x is the first function, that is x is the algebraic function, and sec square x minus tan x sec x is the trigonometric function. So here you can use integration by parts. Here x is algebraic function, that is a, and sec square x minus tan x sec x is trigonometric function, that is t. So which letter comes first in the word let or islet? A letter comes first. That is algebraic function is the first function in this case. That is x is the first function and sec square x minus tan x sec x is the second function. Okay. So you can separate the term also here. Or I is equal to integration of, this is x sec square x dx minus integration of x, this is tan x sec x dx. Understood? So now let us use integration by parts here. Or I is equal to, this is x comes in the front because x is the first function, integration of sec square x dx minus integration of second bracket, this is dy dx of x, integration of, this is your sec square x dx, second bracket closed, dx. Is that clear to all of you? Next, minus sign is there. So within third bracket, let us integrate it by parts. That is the second function. Let us integrate this second function by integration by parts. So here also x is the first function, x integration of tan x sec x dx, as there is no space there, let us write it here. This is the continuation line, minus integral sine second bracket dy dx of what? X, right? Dy dx of the first, dy dx of first function, then integration of the second function, that is integration of tan x sec x dx, second bracket closed, dx, then third bracket is closed. Is it understood now? So both these terms are integrated by parts. Okay. So or I is equal to x into, what is integration of sec square x? Differentiation of which function is sec square x? It is tan x. Minus integration of, what is dy dx of x? That is 1. You don't have to write it. What is integration of sec square x dx? That is your tan x dx. Right? So minus within third bracket x into, now what is integration of tan x sec x dx? That is your sec x. That is differentiation of which function is sec x tan x. That is your sec x, right? So here you can write down sec x minus integration of what is d by dx of x, that is your 1. And what is integration of tan x sec x dx? It is sec x. It is sec x dx. Third bracket is closed. Understood? So next, or I is equal to, this is x tan x minus, what is integration of tan x? Log within mod sec x, the base is e, right? Now multiply by minus sign here, minus x sec x, and minus into minus plus, right? Minus into minus is plus. So what is integration of sec x dx? Can you tell me what is the integration of sec x dx? What is integration of sec x dx? You have done it in method of substitution. So minus into minus, plus is there. So what is integration of sec x? It is log within mod. This is sec x plus tan x, mod sign closed. The base is e. Then what do we write? Plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next problem, that is problem number 34. This 33 and 34 numbers are similar type of problems. Okay, so we will do this 34 number here, and this number 33 will be a homework. They are of similar types. So let's do question number 34 here, and your homework will be number 33. Okay, so number 34 is you have to evaluate this integration. That is integral of cos x into log of cosec x plus cot x bracket close dx. Okay, so let us first write I is equal to integration of, this is cos x log of cosec x plus cot x bracket closed dx. Okay, so now how can you evaluate this integration? This is also integration of the product of two different functions. That means you have to use integration by parts. So in this case we have cos x. Cos x is the trigonometric function, that is t, and log of cosec x plus cot x, that is log. Log of cosec x plus cot x is the logarithmic function, that is L. This is t and this is L. So which letter comes first in the word liet or islet? L comes first, that is logarithmic function comes first. That is log of cosec x plus cot x will be the first function, and this cos x will be the second function. So let us use integration by parts. So therefore I is equal to, which is the function, which is the first function out here that is taken outside? That is log cosec x plus cot x, right? Then integration of cos x dx minus integration of second bracket d by dx of first function, that is log of, this is your cosec x plus cot x, right? Log cosec x plus cot x, that is the differentiation of the first function with respect to x. Then integration of, this is your cos x dx second bracket closed dx. Is that clear? So next, or I is equal to, let us first integrate. What is integration of cos x dx? That means differentiation of which function is cos x? Sin x. So it is sin x into log of, this is cosec x plus cot x, right? Then minus integration of, what is d by dx of log x? Here cosec x plus cot x is taken as x in order to differentiate it with respect to x. So what is the differentiation of log x? It is 1 by x, but here it is 1 upon x. Here is cosec x plus cot x into, again you have to differentiate the term which is assumed as x. So in this case, cosec x plus cot x is assumed as x. Again, you have to differentiate this cosec x plus cot x with respect to x. Okay. So what is the differentiation of cosec x? Minus cosec x cot x, you know that. And what is the integration of cot x? It is minus cosec square x. Bracket closed. Is that clear? Into. Now you have to integrate cos x dx. That is differentiation of which function is cos x? It is sin x. So integration of cos x is sin x. Then you should write this dx. Is that clear? So let's simplify it further. Or I is equal to, this is your sin x into log of, this is cosec x plus cot x, right? Minus integration of, now in the numerator minus, what is common here? Minus cosec x is common. So within bracket we have cot x, minus into minus, plus this is your cosec x, this whole divided by, in the denominator we have, this is cosec x plus cot x, right? Into, now this is sin x dx. Understood? So now here this cosec x plus cot x will be cancelled. So in the next step, or I is equal to, now, so here I is equal to, what is the first function? Sin x into this function, isn't it? Sin x into log of what? Sin x into log of, within bracket, what is there? Log of within bracket cosec x plus cot x. Cosec x plus cot x, right? And minus into minus is plus. Plus integration of, now there is cosec x into sin x. Minus into minus plus, and this is cosec x into sin x dx. Is that clear to all of you? That is minus into minus plus integration of cosec x into sin x dx. So I think you have all, I think you have understood it. Okay. So now again you can simplify it further, or I is equal to, this is sin x log of cosec x plus cot x plus integration of, what is cosec x? This is 1 by sin x into, this is your sin x dx. So here you can cancel it. That is 1. Or I is equal to, this is sin x log of cosec x plus cot x plus this is integration of dx. So now what is the final answer now? So I is equal to, what is the first term? Let us write down the first term. That is sin x log of cosec x plus cot x, bracket closed. That is the first function or first term, plus what is integral sin dx? X, then what do you write? Plus c. So this is the final answer. So I think you have understood it. So you can do it at home. Okay, you can revise it at home. So this question number 34 is done out here. So similarly you can do this number 33. Okay, so this much is for today. Today also we did, I think we did only 5 problems. You revise all the problems that we did today, and you can revise other problems also in this chapter, integration by parts. And in the next online class, we will do more problems on this integration by parts. So this much is for today. So you can copy it.